Okay. Hi, hello guys, nice to see you. I'm glad that we have huge group here because it's really late and probably you are tired after 2 days on this conference. But I hope that you have power for next bunch of knowledge. Today we'll be talking about web app performance. And my name is Brygida. I'm working in Avenga. I am a leader of Front-End Competence Center, senior front-end developer, Angular enthusiast, and GCAT organizer. It's an Angular meetup in Katowice. If you like Angular, I invite you. Next Wednesday we have our meeting, so please come. I have also my own YouTube channel, Speed Date with Angular. Here's some QR codes. If you want to ask me a question or just talk, don't hesitate, write to me. And okay, let's begin. Why web performance is so important? What do you think? Probably that's why that we are so impatient and we want to see our web page right away. Google study says that over 53% of users leave site after 3 seconds if the site is that doesn't load. So this performance is really, really important. Also, in case of SEO, probably all of you knows that Google has some search results. And of course, you are Googling all day, probably at work, because you are looking for some solutions. And it's important to have a good result, because probably you are checking only few first web pages. Okay, here is some Google study research from 2017, probably. And as you can see here, after 6 seconds, the bounce of the user amount. Maybe in different words. User leaves our website without any interaction if it doesn't load. So really, we are super impatient and we want to see the result right away. I hope your users are not super angry and frustrated like that guy. And maybe now we can check what we can do to optimize our website and how to measure it and which tool we can use to know what's going on. So first, we will focus on initial load performance metrics. Then I will tell a few words about Core Web Vitals. And we see probably a few tools like Lighthouse, from DevTools, something like that. And you see now a lot of names, shortcuts, and what now? I will try to introduce all these metrics to you in few words. I hope it will be simple. Okay, so first, very important metric is time to first byte. So it measures time between our navigation to the first byte of our document response, which is received for the browser. So why it's so important? Because this first byte, it is a minimum requirement to start rendering something on our screen. So that's why. And I can go back to our research, and as you can see, 3 seconds. And if we have this 3 seconds, and we have only 3 seconds. So what we can do with this metrics? Probably we should have good hosting, use CDN, think about the bundle size of our application. Of course, yes. Also, this metric is a predecessor to the other very important user experience metrics like FCP and LCP. And here is the second one, FCP, first contentful paint. And this metric measures time to render first visible element of our website. So, as you can see here, this is the result from web page test, and I was checking NG Poland website, and as you can see here, we have the FCP. So here is render first visible element, and it took 3.5 seconds. So the result, it's not good, because as I said, we have 3 seconds to render whole page. And here we have only a scratch. Okay, we can go next. Now, largest contentful paint. So this metrics measure the time from the navigation to the first to the rendering of the first largest content, visible content on our page. So here is also the result from the web page test. And as you can see here, this is our LCP image. It could be also a text, but let's stay with the images. As you know, it is very important to prioritize our LCP because it should be rendered as soon as possible. Because as you can see here, the time was over 4 seconds, so it's really, really long. And remember, never lazy load LCP image. But how to recognize that this is our LCP image? We can use, for example, Lighthouse. And it is very easy to do this. Give me a second. I will find NG Poland website. I do this before because we have a shortcut because my presentation is super long. Sorry. Okay, so here we have the results about the performance. And as you can see here, we have the first contentful paint metric, and it is so-so. It's 1 second. Next, we have largest contentful paint. It's about 4.4 seconds. And here, you can filter some kind of tips from the Lighthouse, what you can improve by the correct metric. So I will choose LCP. And for example, here, we have information that largest contentful paint image was lazy loaded. So it's a huge mistake. Don't do this. It shouldn't be lazy loaded. What next? Here is also, okay, because largest contentful paint, you can split it to four separate phases. First is time to first byte, so we know this metrics. Next, we have load delay, load time, and render delay. So load delay, this is the biggest problem. So why our image was loaded so long, because it was lazy loaded. So first, everything else was rendered, and then we lazy loaded our image. And this is the main cause of this high score here. Okay, so this is mainly everything for largest contentful pane, and we can move, maybe not here, but here, to the last one, cumulative layout shift. And this metric is, think about like, oh yeah, I think all of you experienced this. For example, you were reading something on the page and poof, some advertisement appears and all of text goes down, or maybe some images was lazy loaded and you misclick some button. You know, it could generate really serious problem. So it measures visual stability of our page, and it is the sum of layout shifting in some a period of time. It could be around 5 seconds. It depends on the tool. And this is one of the metrics without the unit. And as you can see, the good result is under 0.1. And what's more, CLS and LCP are core web vitals. But this in the minute, because I want to show you the web page test result and how to measure all of this. I've prepared some tests before, and it's connected with DevConf. And as you can see here, we have a lot of metrics. Now we know time to first byte, first contentful paint, largest contentful paint, cumulative layout shift. So we know all of this. And as you can see here, we have all of screenshots in the period of time. And maybe I will go to, I think here. Not exactly, sorry. I want to go here because it's biggest view. And here we have some kind of a legend. You can see that when layout shift was appeared, and where we have largest contentful paint, or we could have also largest contentful paint with layout shift, because we forgot to put width and height to our image, and so on and so on. It's very important because all of this shifting appears because we are loading something dynamically, or just lazy loading images, as you see before. And look here. First, where is largest contentful paint for DevConf? In the end, because it is the background image. This is the image. Yeah, this all of this. So it should be prioritized, and it should have dimension and correct size. Yeah. Okay. And here's, because this web page test page give us a lot of opportunities how in which we can change the environment. For example, we can check our website on mobile, desktop, also on different browsers, on different network condition, and also in different localization. So this is the simple configuration, but you can also do some advanced. So choose. Here we have a lot of configuration, but I can't see Poland, but probably it's normal. You can also choose the browser, the phone, and so on and so on. So this is very important. So as you can see here, you can check your website in really different environment, in very different circumstances. Okay, let's go to Web Core Vitals and why they are so important and what they are measured. So Core Web Vitals, they are the three key performance metrics that capture critical aspects like loading speed, so we know that this is LCP, interactivity, it is the next metric, interaction to next paint, and the last one, visual stability, it is CLS. And why this is so important? Because these metrics are used by Google as a ranking factor in search results. So if you want to be higher in the rankings, you need to take care of these metrics. And here a few words about interaction to next paint. It is quite new metric because it was introduced in March this year. And how it works, what is measured? It measures time between user interaction to UI change. And what is user interaction? You can, for example, it can be mouse click, tap on the screen, or key press. But what is important, for example, hovering or scrolling, it's not taken to the consideration. So only click, tap, and key press. But what happens when user interacts with page? Like this, probably you know some people, which are pressing all the buttons right away. So how it is measured? First, user interacts. Maybe not like that cat. Next, we have input delay. And this is the time between user click the mouse or press the button to event handlers receive the information that something happens. Then we have processing time. So all JavaScript stuff under this key press are done. Then we have presentation delay. So maybe, I don't know, we should change the color of the button or do other layouting or painting stuff. It is done here. And then we have UI update. So it's quite long road between user interaction and UI update. And give me a second. So, how to measure? We saw Lighthouse. It is pretty easy to use, Lighthouse tool. It gives us some tips, what we can change, but sometimes they are really hard to understand. It's, you need to think, or maybe use the other tool, like Chrome DevTools. And this is my main point, performance tab. I don't know, do you use performance tab? Anyone? Great. So, you know that now it has new layout, it's new, it has new things. For example, you can see here Core Web Vitals. You have to remember that if you want to have a result of INP, you need to click a button or interact with your page. Okay, but what you can do, you can record some interaction with your page and check the result, check what happens under the hood in the main thread of the browser. Yeah, I know, it looks really, really scary. A lot of colors and charts. For me, yeah, in the first meet, it was really, really scary, and I didn't know what should I do with it. But let's start with the beginning. Here we have the task. And under the task, we have some yellow elements. And yellow elements could be some events like mouse click, scroll, and so on and so on. And it's connected with JavaScript. Then some purple elements are connecting with our style, so recalculating, layouting, and so on and so on. The green ones, they are connecting with painting, so everything which we can see. But here is the browser render pipeline, and I will briefly go through. So as I said, the yellow ones are connected with JavaScript, and they could introduce changes in our DOM. So also they could change the style of our website. We can, for example, add new element or sort data and so on and so on. The next one, this is the style, recalculated styles. So our browser needs to compare which style should be added to which element on our website. After that, of course, it is done by selectors. We all know CSS selectors, I hope so. And when browser knows it, then the recalculation phase starts, so all styles are recalculated. Then we have layouting. So now when we know all the styles, when we know how our element should look like, we need to think about the dimension, geometric of our web. And here is all the stuff connecting with margin, padding, flex layout, and so on and so on, because it's connected with a size of our element. And what's more, this purple part are really hard to optimize. The next one, paint. This is everything connected with visual changes. So it is just painting the pixels. So we are changing background color, maybe some shadows, and so on and so on. So this is, the browser is just painting the pixels in some kind of the layers. And after this, the composite phase. So when we have styles, layout, and all this paint, our elements should be positioned in the correct way. Because, you know, for example, we want to have like here, we want to have this element above our image. So it is very important, sorry, to do this in correct way. Okay, let me come back here. And what next? Because now we know what these colors are. Of course, we have many other, but it was the basics. Now let's talk about long-running task. Because, as you know, I hope you know, JavaScript has only one thread, and here this is you can see the main thread of the browser, and if task is too long, so took more than 50 milliseconds, we name it as long task. So user could know that something is wrong, and because our page is not interacting with him or her, whatever, because our browser is analyzing all this stuff in this one task. And what we can do with it? Okay, maybe now. One more thing, because we have the blocking time. And with blocking time is connected one more metric, total blocking time. And this metric measure the time after FCP, so we know this metric, where the main thread was blocked. So it sum every task over 50 milliseconds, but take only the amount above the 50 milliseconds. So like this, we had a task with takes 83 milliseconds, but blocking time was only 33. So this is the important part. Okay, so what now? Of course, we should be like a Sherlock Holmes and find and analyze the problem. Yeah, it's not so easy sometimes. But when we find the main purpose, the main cause of our blocker, we should think about splitting and rescheduling our task. So, but how it works? We have event loop in JavaScript. I hope you know this concept. If no, it will be a short recap. It is very simple concept connected. This is some kind of an endless loop. We really like endless loop. And in this loop is waiting for tasks. If it has some, the tasks are executed, and then it sleeps and wait for new ones. And how it works? First in, first out. So the rule is really simple. So what we have here, we could have some events like mouse click or probably scrolling. We have also here the set timeout. So the callback from the set timeout goes here, and the new task is created and executed. And this is micro task. But we have also micro tasks, and they are a part of our micro task. So we have this big gray task, as we said, have on the on the chart, flame chart, and we can divide it, this big gray task, to the smallest one, and we can use here it's some kind of the promise resolution, and this micro task should be executed before rendering, before our long gray task is ended. So first micro task, then all micro tasks, rendering, and then the next macro task. So we know this. So now the riddle. Okay, so what will be the order? If you know the answer, please let me know. Are you ready? Okay. So this is the answer. Yeah, all of you know why? Okay, we have here console log and the second one console log, and they are just synchronous. So we have 1 and 5. Next, we have set timeout, and set timeout is creating new task. So it's okay. So it's almost the last one. Then we have promise resolve then with set timeout. So we schedule this micro task, but when this micro task is executed, it's schedule set timeout. So okay, so the new macro task. And here there's also promise resolve, so it also schedule micro task. I hope it's now easy, but maybe we will check it in the code. I have here promise resolve 10, and it's changing color of the button to the yellow. Next, I have request animation frame. First is changing pink, button to pink, then red, and the last one is set timeout. Okay, and here is my super simple application, and we can record what's happening then. But I want to say you one more thing. When you are recording the performance, of course you can turn on the throttling of CPU or network throttling to simulate different circumstances. Okay, so let me record. And as you can see here, we have the blue one. But it's not so easy to find something here. Okay. So here we have our event click. And as you can see here, the button changed to the red, then to the blue one. And why? I will just find, okay, here, because this is the name of our method, scheduling test. And we have here scheduling test. If we go down, we have here set timeout and also request animation frame. somewhere here, we should have, I don't know what. Okay, somewhere here we have our micro task from promise resolve. Somewhere here probably. But what is more important, here we have animation frame. And request animation frame, we first change our button to the pink, then to the red. But we saw only the red one. Why? Because all of tasks which are requested to the animation frame are in the one, only in the one task here. And we have only one painting. So here we have one animation frame and the second one. Also, we have here this beautiful arrow, and you can go to the place where it was scheduled. So here it is, first and the second one. Now we should check and find our set timeout, and it's probably here, I hope so. Let me check. Yeah. We will see it. Yeah, we will see it somewhere here, probably. So, as you can see, we have here this micro task scheduled, then animation frame, and why we don't see the pink one probably, or no, yellow, the yellow change, because here we don't have the painting. The UI doesn't update. First, we had scheduled animation frame, then we have the UI update. That's why we also see only the red button change. Where is it? Here. And then we have the set timeout change, because this is the last scheduled task. Okay. So that's it. You need to just play around and familiarize with all of these colors and frames. It's a little bit complicated, but here you have all the frames in the time. Also, maybe we can check the performance on other tab, other site. For example, DevConf. Okay, let me check. And probably you can click the speaker one and click stop. And here we have a lot of things, but I want to find the place with click. Here it is. It is also very important to see to the interaction. It's very useful because you can easily find the place where you click, or just do some kind interaction with your page. So as you can see, here we have the event click, our page, do some recalculation, start layouting, and then some painting. Okay, maybe I will skip this slides and go here. Here's the really nice page. It was created by one of the developers from Pushbase company. And here you can play and check how it's work with layouting, painting, and just do some performance tests. Like, okay, for example, we insert layout, and then we want to try layouting test. And as you can see here, we have a lot of purple work. So work connected with layouting, because this button was like changing its size. So here is the QR code, and you can play and check it. And here's also the QR code to this tag blitz. You can check what is going on under the hood, so which styles which styles affect layouting or painting, and so on and so on. It's super useful when you want to understand this purple and green parts. Okay, but let's going on to the next thing, bundle size. You know, this is very important. Why? Because we don't want to load, because we want to load our page really quickly. So if it has big size, it will take a long time. Also, if we have a good connection. So what we can do? First thing, and probably all of you know it, is minification. And so it's code not looks good, but it's only for the browser. But as far as I know, we have also in the DevTool some prettify tool or button, and then poof, it looks very nice. So remember about minification and combine your CSS code, JavaScript, and HTML files. And please remove unused CSS and all this code. I know that we like it, and all the comments in the codes and so on and so on. But this is the small things, but can improve our bundle size. What next? Lazy loading. All of you know lazy loading. We have to think what is important for our page and what we can lazy load it when we really need it. Also, it's the first strategy. So we can say to our browser, okay, this is not so important, render on the stuff, and then take this script, do this under the hood. My favorite, please check your dependency. As we are developers, we really like different libraries, but sometimes these libraries stay in our application forever and nobody is using it. And it stays because we are just testing one control, another, and then choose the third one, but nobody wants to remove the two of them. Okay, so we have a lot of different bundle analyzer. You can Google them or pick one of them. The rule is probably the same in all. So just install and check the results, what's going on. It's a quite nice graph where you can check all of your dependencies. And the last one, but for me very special topic, is images. Please use CDN for images. Now we have the special ones, which are specializing exactly in the images, like Netflix or Cloudinary. But this is not only delivering images. These CDNs are focusing on transforming, optimizing our images. We can request for our image, but we can say, okay, we want this size, this resolution, and this format, and so on and so on. The CDNs could change the format of our image. For example, we have WebP format, but our browser is old and doesn't support it. So the CDNs send, for example, JPEG, and it is done automatically. This is super, super cool. And one more thing, use the modern image formats. Now it's really important because also in our DevConf page, we have old formats like JPEG. But why we should use them? Because they are smaller and they have the same quality as the other ones. So please do some tests at home and take one of the picture and change its format, convert it to the AVI, for example. You can see that the size of this image could be to 50% smaller. Not always, but it could be. And the quality is pretty the same. So check it, really. And as you know, I am an Angular enthusiast. So I need to put something interesting from Angular. It's ng-optimized image directive. I put it here because you can use everything what this directive does in your project, because this directive does a lot of things under the hood. So, as you can see here, we have image tag, and we need to change normal SRC to ng-SRC. That's all. And what this image directive does. First of all, it enforces using image CDNs. Where else? So this is the first benefit. But of course, you can use a normal path. It's no problem. It prevents layout shifting. So it requires width and height. So as we know now, it is important to avoid this layout shifts, because this CLS is the Core Web Vital. So if we want to have good score in the Google rankings or others, please remember to use width and height to your images. What's more, it also informs us when we set wrong size of our image. And it's great because this small thing could really improve our web core vitals. The next one, if we have a LCP image and it isn't prioritized, we will get an error. Please prioritize this LCP. And hooray, now we know that this is our LCP image. So we have some kind of a bonus. What's more, all of the other images where we set this priority are lazy loaded. So here, and they have also first priority out. What's more, it also auto-generates SRC set attribute. So, of course, you can do this on your own, but we can say here that, okay, I want the image in this size and this size, and so on and so on. So this is really, really nice. Moreover, it's auto-generating the pre-connect link to our CDN. So this directive does a lot of work for us. And here is some kind of some kind of the proof that this image ng-optimized image directive working. Here's typical application with text and images, of course with my cats. And here's the result without using this directive. And as you can see here, the first contentful paint is quite poor, and also largest contentful paint, that's really, really bad. But after using ng-optimized image, it's totally different. We can think about largest contentful paint. It could be improved, but I just add only this directive, nothing else. So in my opinion, it's super cool that it's just done it magically. Of course, you also can have this kind of improvement, but you have to remember to add this lazy loading or some prioritize. You can also add this src set attribute and this pre-connect. So it's a lot of work. Of course, what's more, you have to set width and height and so on and so on. Okay, so as you can see, it's a lot of stuff, a lot of different metrics that you have to remember, know how it's work. We have also a lot of tools. Oh, I forgot to show you, so maybe I have okay, maybe I don't have time, but I want to show you also, this is the web page, but you can, for example, focus only on Core Web Vitals. And here you have the results about largest contentful paint, CLS, and total blocking time. But here is also information about real world usage of this page. So this is not only your test results, but you can see the real results, how any other user gets. So it is also very, very nice. Okay, so we are out of time. I could say something more about SSR or any other optimization, but maybe outside of this room. So thank you very much. I hope it wasn't boring and you learn a little bit about these metrics and about all these tools. And I hope you will play with it at home. Thank you.